Good morning. So today we're going to do a little experiment where we look at the cooling curve of chocolate. So I have chocolate in a water bath and I've melted it. So it's already melted. The water bath just makes sure it doesn't burn when it melts. A little food trick for you. So I'm going to move this off. What I want you to do right now is to find uh, your phone and open up the stopwatch. And what we're going to do is we're going to take temperatures as this cools down. This will allow us to see that temperature drop as it loses heat to the atmosphere around it and cools. The temperature will change. When we hit the point of solidification, also known as the melting point, where it moves from a liquid to a solid, same temperature goes from a solid to a liquid, then it will stay still just for a few seconds, and then it will drop again. So you need to find your stopwatch on your phone, and we're going to take a temperature every 15 seconds. This might not be the exciting part of your day, but it will give you the data you need in order to make your curve. So pull out your phone and take your initial temperature right now, hit start, and every 15 seconds, just take a temperature. Keep taking temperatures. You can see that thermometer dropping. It's dropping because as it cools, the energy is removed from those molecules and they slow down. We see that in temperature. Remember, temperature is purely the speed of the molecules. Keep taking temperatures. We're slowly approaching the point at which solidification will start. Remember, when solidification happens, instead of changing temperature just for a brief period of time, it will keep losing heat because the heat will still be removed, that thermal energy will still transfer into the atmosphere around it. But while it's doing that, instead of decreasing the temperature, the molecules, instead of slowing down, that removal of heat will cause them to reform their intermolecular bonds. And that attraction between those molecules, it requires energy removal for it to happen. We will see a brief pause in our temperature drop. It will seem like it kind of hovers around the same temperature just for a very short period of time, maybe 2-3 readings. You'll notice that all of a sudden the temperature drop really doesn't happen very quickly. Then once we get past that point and solidification has started to occur and those bonds have started to reform, once we get past that point and there's solid chocolate on the thermometer again, maybe not the entire test tube, but the thermometer itself will be coated in solid chocolate, then we will notice a change again in temperature. And the temperature will drop significantly again. So keep taking temperatures every 15 seconds. Now, I know you might not be getting perfect temperature readings because this is a video of a thermometer. However, this is just the general idea, right? This is just about understanding how that temperature changes. And by just watching this video, and you can rewatch it later, you'll notice a huge change in temperature, then a brief hovering around that temperature, and then it should change temperature quite quickly again. So at this point, we should be on the other side of that temperature change. We should be back to it dropping in temperature because we should be on the other side of the solidification process. And like I said, the entire test tube may not be solidified, but the chocolate around that thermometer probably has turned from a liquid to a solid. And that's the only temperature really that this thermometer can take. And you can see now that our temperatures are dropping again. And that's because, once again, the thermal energy is being released into the atmosphere. That's that heat transfer. And as that happens, those molecules will slow down. And as they slow down, we see that temperature change. And that's because that's all temperature reads, right? Temperature just shows me the speed of the molecules. So at this point, you should have enough to give yourself a nice little cooling curve. Remember, we're only doing the solidification process. We're just doing that melting point. We cannot really turn chocolate into a gas and then be able to change it. So it'll only be half of our cooling curve, the bottom half of the cooling curve. But you should get a very nice pattern. Pretty soon we will notice it doesn't really change much, and that's because we'll probably get pretty close to the temperature of the room soon. And then, of course, cooling will not occur effectively. So draw yourself a cooling curve, see what it looks like, and wherever it flattens out, that is going to be your melting point or solidification point of chocolate.